Somehow this device is not working, but I will try to work without it. So, first of all, I'd like to say that it's really pleasant to be here on stage. It's my first experience actually on such a big event, so if I make some mistakes, do not judge me too much. I will try to avoid them. But anyway, this presentation is about architecture. It's about architecture evolution, specifically in startup projects. Yeah, so with this presentation, I don't want to teach you how to do properly or not, because we learned a lot from the previous one, thanks to Henning, actually. It was very interesting. Here I want to share our experience, our project experience, how we built our project, and how we plan to transform it into something bigger than just a startup. A few words about myself. So, I am CTO of some kind of small company, startup company, and it differs a lot from being CTO of BMW or SAP, of course. So, despite I'm in charge of almost all technical stack, all technical processes in company in development of the product, I still need a CTO to think strategically and think how will we develop our product further. Still, I'm developer inside, and my way of thinking is developer-like. And I'm talking like a developer, I'm doing like a developer. I like to do things instead of talking, yeah? And that's helped me, I think, with my role a lot, yeah? I'd like to bring some information about our product, because it's important to understand from the beginning about what we will talk next 60 minutes. So basically, Regiondo is software as a service product. It's a B2B product, so it's a booking system for leisure activity providers. And our main customers are businesses, not the consumers. And this actually also defines how to develop our product further. So basically, the idea of the product is we allowing our suppliers to manage their products, their availabilities, their resources, their staff, actually, via Regiondo as a software platform. And also it allows to sell tickets for these activities, of course, on their own ticket shops, own websites, but also offline with point of sales, which we provide as well. But also we have integrations with many different platforms, marketplaces, and basically channels. So we allow also to sell there, and then all the bookings will be managed in Regiondo. So this is our idea of our product today. But it was not like this in the very beginning. So in the very beginning, Regiondo was a completely different product. It was basically a marketplace, like we integrate now with. So it was B2C product. It was e-commerce startup selling tickets, or let's say gift vouchers for touristic activities. And basically, why did we change from being like this into a completely different product? We started as a startup, and first of all, to answer next question, I like to highlight the question, what is startup at all? Yeah. So what does it mean? Not the word, but the general definition in reality. And how many of you are working in startups? So pretty some of you. And so you may know, but what is startup actually? Is it always high technology? Well, not exactly, because there are many startups with different business models. Is it about innovation? Well, good startup should be innovative, of course, but still you can take real idea, existing idea, and build another one, Airbnb, but better, for example. Is it success? Does it mean success? Not at all exactly. I mean, there is no guarantee of success, yeah? So it's good if you build successful startup, but many of startups unfortunately fails, but some of them becoming really good products. So basically, For myself, startup is first of all state of mind. State of mind of developers of business to solve the problem without obvious solution, because if it would be obvious solutions, then many other companies would do this before you. With limited resources, because startups basically means always that you have limited resources, limited developers, limited money, and so on. And you need to be fast, really, to be in time, to be on the market. Otherwise, you will fail. And of course, there is no success guarantee, because you never know when you start a startup if it works or not, if it's expected or not. But if you build successful product, you must understand that it should be able to grow further. So if you build startup which is super successful, but you cannot scale it further, then it's also fail, unfortunately. So what does it mean for developers? Because we're on developers conference. What does it mean working on such environment, such company? Basically, it sets very specific development process in startup companies, which actually I would say is feature-driven development. Yeah? Because basically, all you plan to do, all you design and all you build is always connected to the features, to the business value, which actually is requested by your end customers, by the business. Yeah, so business comes to you, or you need to ask the business, what features should I implement? What should be included in my domain? We all know about domain-driven development. Yeah, so what should be included there? And actually, developing by features, developing by business request, it's always risky, because you are on a high risk to build a product with wrong architecture, to build it wrong, and then you will not be able to scale it further when you have successful product. And also another thing is when you are building your minimum valuable product, it's what you start with. But generally, it will adjust. So after you have minimum product, you have new requirements, new ideas from your business, and you change it, and you have another version of your product. And then new ideas, you need to change again the product. And at the end, as it was for Regiondo, you probably will have completely different product from that one which you started working on. And this, as developer, you need to understand. If you go deeper in Regiondo case, so as an example to explain, in the beginning, we had a marketplace component. We added, so for marketplace, actually, we took typical e-commerce system, the most popular at the moment and one of the most popular now, Magento, actually. And we added some components, extended it with ability to create your own product, with ability to sell basically vouchers and redeem them later, with some advanced recommendation engine, advanced search engine. So we had some set of components, and it was pretty simple. But then we got our first big client who actually requested something more. And we were thinking like, okay, we can do this. And we added some kind of pro version of our system, which added some additional features like ability to make changes in your design on your page, or ability to see more detailed statistics for the sales. And later on, thinking on this request, we added also advanced dashboard, which allowed actually to make much more to our suppliers, to our clients than they had before, with management of product, management of bookings, working with customers. It's some kind of CRM system, what we added. Then we added we went even further, and we added resource and availability management in our system. And this was actually pretty complicated component, because it really replaced all the logic for stock calculation, what we sell, and for availability of the product, which products are actually when available, which time slots exactly you can sell. And later, we transformed our product completely into booking system, booking platform, and basically we switched off initial marketplace, initial components, which were basically the main components in our minimum valuable product. So same things, but in architecture. So as I told you, we had an e-commerce engine, and we had only 2 components. And all the questions which we were discussing in IT together with business at that point of time, all our domain was basically based around e-commerce, and we were discussing visual design and usability. We were implementing different changes in UI. We were implementing A/B schema of UI. We were talking a lot about SEO because we wanted more sales on our website. We were talking about search optimizations for customers and geolocations optimizations for customers to sell even more tickets, like typical e-commerce shop. And the main trackable thing for us, it was conversion rate. If we have higher conversion rate, we have higher sales, we are really on a good point. So this was our concerns and our problems which we were solving in the very beginning of our journey. And in 2018, our architecture was much more complicated. So basically, we were continuing developing our engine, which was initially, our database become much bigger with some really data which probably we can delete from it, but we didn't do this. We added another databases on the ground. We added public API to make these integrations with other platforms. We added queue management system to proceed requests on the ground to make, again, a better experience for our customers. And of course, we added many additional components additionally to initial 2 or 3 ones. And this was in 2018. We started reviewing our architecture. Why? Many reasons. Of course, as we are a B2B product, it's very important for us to be online as much as possible, close to 100%. Because if our business is not working, it's not only our business not working. It's not a business of our clients is not working. And this is really high responsibility for us. And we had some issues with availability, and we started thinking what we can improve there. But also, we started thinking strategically, because in 2018, we already started due diligence processes with our investors, with further acquisition talks and so on. And it was also a lot of talks with consultants regarding our architecture, and we basically were talking completely different things than in the very beginning. So main topics were reliability, scalability, because all this we need to deliver the best experience for our customers. But also, of course, performance, development process. Development process is also very important because we were growing not only as a product, not only as a business, but also with our technical team. So we needed to improve our pretty simple processes which we had before. We started talking about deployment processes, how we do deployment, how often we can do deployment, how they are reliable. And of course, all these topics were related to architecture. And architecture is something which you need to talk for strategically goals. Yeah? Anyway. And basically, we analyzed all the things, and we made some improvements to increase stability of the platform, to decrease problems which we had with availability of the service. And we understood that, okay, we have a product which is working currently. We have no big issues at the moment, which we cannot solve with small changes. But basically, we have a monolithic product, which is not really exactly bad, but still thinking strategically, it has some advantages and disadvantages. And if you talk further about advantages and disadvantages, so of course, pros of having monolithic product is quite short list for me, but it's basically based on the easier development and faster development. And this relates basically not to the question, is it monolithic or not? It relates that it's easier and faster to develop monolithic products for people who were building it. Yeah? So it means you know your product, you know all the dependencies, you know how it works, you know the state, and you can easily extend it, you can easily debug it, and it's easy. And of course, one of the advantages is consistency, that you have one application which you can easily understand and debug and support from first view. But at the same time, if you think about scaling and strategically, then it's really hard to scale such kind of product. Of course, it depends on the architecture inside monolith, but components in monoliths are often highly coupled, yeah? And you cannot scale them separately, one from another one. And this actually is a concern because some of the components in our product are already being used more than others and already have much bigger traffic than others. Why not to have ability to scale them separately from the big monolith? Yeah? And it's hard really to reuse components in monolith. I mean, inside this monolith, probably you can do this, and there are many patterns for this, but if you want to build something a bit different, probably it will be hard. And it's like a black box. Black box for people who are looking at it outside, so for new developers, yeah, for newcomers. It's hard to learn this product for newcomers. Of course, you can write a lot of documentation, but still having monolith product after a couple of years of development, well, it has some complicated stuff, yeah, which you need to really learn. And it's complicated to test it because basically it's hard to test separate components because they are coupled. And basically the testing usually is done on the level of all monolith, complete monolith. And this is also not, it takes a lot of resources, it takes a lot of time for every deployment. And this basically leads to unstable or delayed release management. So you can live with this. I mean, it works. Why you need to change? Because if you change, you need to answer a question how to change. And then question, do we know really how to change? But working with this kind of project, with monolith, earlier or later will be, I will name it workaround-driven development. Because on some point of time, it becomes harder and harder to extend it with new functionality. And moreover, business comes to you and asks for some new additional feature, and you understand that this feature is basically against few previous one. And then you start building workarounds to support both of them. And this is really a problem because at the end you will end up with the principle, don't touch if it works, and basically your business will come to you, ask for developing something, and you will say, oh no, it's too hard, too complicated, let's postpone it. Well, for business it's nothing else to do than postpone it. But still, with such approach, on some of the Christmas seasons, when you have increased sales, increased traffic, you will end up with a big fail of your product. And the important thing that on this step, when your product is really down and you're trying to fix it with some additional workarounds, it's really much harder to fix it than if you are prepared for it before. And if you don't have this issue at all. So it's much easier to be prepared for such case and avoid it than fix it afterwards, because afterwards you will have no time for this. So what to do then with the product? How to fix it? Several ideas will come in your mind probably. So first of all, you will think, okay, we need to do refactoring to improve its quality. You can do it, but business will not understand you actually on this, because this is something like a never-ending process, and you can start refactoring one component and then go to refactoring another component, and then you will understand that, okay, the first component is really still not so good, and you will return to it. And really, from my experience, this process is really hard to manage and hard to plan. Yeah, and you will do it probably on background, given some percentage of your time, but it will really demotivate you and your colleagues and business at all. And probably even it will add new bugs in your system, because if you're refactoring, you do it better from the code perspective, but probably it will not work from the business perspective. Second option which I see is complete rebuild. Yeah, so this sounds good, because if you build new product completely from scratch, we can build it as a state of the art. we can build the best architecture, we can make it everything as we want, we can plan it, but still it's really very, so first of all, it's very expensive, yeah, because you need to stop doing what you're doing and completely focus on building the same product, but differently. And basically it will lead you for double work because you need to still support your legacy product and you will still develop new one. And basically to avoid this double work, you need to make complete code freeze or feature freeze, something like that, and then business will not understand you and your customers will not understand you because it's really, if you're a startup, it's really not easy to say to answer your customers that sorry, this feature will be implemented in 2 years because we are doing complete rebuild. And the third step is step-by-step evolution. So this means that you taking part of your application, building them from scratch, but not complete application at once. So in this case, only limited part of application are affected at once, and additionally, you can really have defined plan of migration. You can list steps which you want to do one by one. And risk is limited actually to single component which you are building currently. If it doesn't work at the end, it's bad. I mean, it's a wasting of time, but still your product is not affected at the moment. And of course, it's really easy to roll back in case if you do something wrong. So having this in mind, this step-by-step migration, you need to understand why you're doing this. And we sat together with our IT team and we asked ourselves, like, why do we need to do this? What concerns do we have? And basically, these concerns are pretty obvious. We're concerned about database structure and its size because it's really hard to scale big database. We are concerned about some performance peaks. They are mostly connected actually to database when we have some lockings and so on. And we're concerned about slow development process and a lot of legacy code which we still have in application, which was already switched off, but we need somehow to deal with it, to support it still. And this all leads to complicated deployment process as well. But is it enough to define the technical problems? Well, we need to define also business problems there. So we need to talk to to our business, to your managers, to sales, to directors, and talk about business needs and try to understand, as we have heard from the previous presentation, how application flow is working. Yeah. So for this, we need to divide the project into logical parts and decide which components are really critical and which components we need to have stable as is possible and which components makes pain for us, for business, for our customers. And you need, of course, to visualize this, yeah? And now I can jump just quickly because we talked a lot on this conference about domain-driven design, and I believe you know pretty much about it. But I want to just quickly jump into domain-driven design because basically domain-driven design is about business. Yeah, it's about business needs, about problems which you need to solve. It's not so technical question from the beginning, and you need to start from this. Define your core values and core logic from your business. And it expects, actually, domain-driven design paradigm expects that you will be in strong collaboration with all parts of your company, with all parts of your business, with all domain experts. Who are these domain experts? There is no answer, so you need to define yourself. It's basically depends very much on the companies where you're working, on the products and so on. But basically, for domain-driven design, everybody knows what it is. Just a question, who is really using it in real on production in your products from you? So not so many people. We are talking a lot, but we are not using it. And we must start using it because we cannot talk only about technology. So, first, we need to work in our problem space. we need to define our core domain, and core domain in this case, it's a bounded context, bounded context which, the main bounded context which developed as a strategic initiative of your business. You need to make really high-level strategic analysis of your components, of your logic, of your flows, and define steps which your application and your business working on, really we did it on previous presentation. And we need to build the context map. And based on this context map, we can go further. After problem space, you are in solution space, and only after solving previous part, you can talk about technology. Only now, you need to start planning implementation of your bounded context. It's really wrong, and I would not recommend to start from technology, because then you will build probably the best architecture which will not work for your product. Well, bounded context in this case, it's an abstraction layer, abstraction of your domain names. You can have one core domain, and you will have several subdomains, and each of these subdomains will have its own bounded context. And basically, it's important that this bounded context is really implemented with the idea of solving or creating a solution to the problem which were defined with your core domain. So if you back to our Regiondo product, this is very simplified picture how to basically understand your application. In this case, we understood that, okay, we have some product which has basically, so when customer is buying or when customer is selling the product always has availability and stock management. So it means we know, because we sell in experiences, we know that some experience is available on particular day, particular time. And basically, product and availability will lead to placing of booking. So this is another part of our application. Booking can come also from the channels, from integrations which we have in our system. And basically, from bookings, we will do accounting. And then later on, we will end up with some reporting. Of course, we have bigger amount of subdomains, let's say. But as an example, it works perfectly. So it's something very abstractal which you can start from. After doing this, we need to make data structure review. And basically, this is not only the data structure. So it's not about your database. It's more about your implementation, about your models. You need to, in existing product, already do decoupling of the data. So if you have some strictly connected models from not connected subdomains, you need to split them. And you need to clean your database before going further. And basically, as an example of data structure review, so if you do it, we have, for example, some 3 tables or 3 data models, and they are highly coupled to each other, connected. And at the end, we will have probably more data models, but they are really cleanly decoupled, and they do not have any connections to each other. So now I want to talk also about service-oriented architecture. So this is additional pattern, additional style of development, which basically is about the development when services are provided by components, and these components are serving the services via the network protocol. In frames of DDD, it also means implementation of operations which are not conceptually belong to one single object. So it's a service which can basically work with several objects and returning services to your component. So by us, services are considered in this case as applications, single applications, which implement solutions in frames of our bounded context. And having this in mind, we can talk also about layered architecture. In layered architecture, also known as NT architecture, we need to separate components into different layers. We have presentation layer, we have service layer, we have domain model, persistence layer, and data layer. And the main idea that components on all these layers should not communicate with components higher. So the communication should go always from top to down. And let's talk about the service layer, because this is what we started doing in Regiondo. We started implementing our service layer. Basically, if we take our initial context mapping and the model's data model review structure, we can already define which services we can include in our application. In our case, we have around 20 services which will cover more over our functionality. Here it's less, it's just as an example. But I don't want to have services in amount of hundreds, yeah, because then it will be really hard to support them. So this is important, how you split your domain into subdomains, and this will help you to define properly which services basically you need to develop. So if we talk about the particular service which we need to develop, it also can be defined by different steps. Yeah? So first of all, you need to think about the tech stack, because now you know the business needs, and you can analyze basically how to solve these business needs. After defining tech stack, you need to check your bounded context and build, let's say, endpoints, yeah, which your service needs to serve based on the context which you have. And these endpoints later will be used by your application. And then it comes implementation itself, and at the end, you need to connect your service to your application, basically. And if you go further, step by step, regarding the tech stack, you can define tech stack as you wish, but I would recommend to keep it as simple as possible according to your needs and according to the business needs. In our case, basically PHP and MySQL or MariaDB works quite good, yeah. And we have PHP developers mostly, and basically for services which are okay with this tech stack, I would not do anything different. The only thing for us was that before we were hosted on physical servers, yeah, and now we're considering going with our services with Kubernetes and with cloud solutions, yeah, because this basically will allow us to make this scalability per service and allow to automate the process of scalability and allow to automate the process of deployments and support of our application. So these are the services which we define for our, let's say, first application, but basically service-oriented architecture itself, it allows you to use any tech stack as you need for every particular service, because basically at the end services will communicate through the unified adapters through the network, and basically one service doesn't care which technology is used in another service. And this is, for example, the whole list of technology which we somehow use or plan to use in our system. Yeah? So it doesn't mean that we already using everything from it in Regionda, but now we are part of bigger company of Johann Schweizer mydays Group, and this is mainly stack which we have available for further implementation at Regionda. If you go to the next step, it's endpoints. How to build your endpoints, how to understand which endpoints should be. Simply check your bounded context which you built before and check your application. Analyze context and define these endpoints which will solve actually problems which or solve the concerns which you have, make the solution for your domain. And of course, it's important to document this, because this is the very beginning of your development of the service, and all what you defined you need to put somewhere. Yeah, and we use an OpenAPI docs actually for it as annotations in PHP. And it works pretty good. So we define our docs, and then endpoint by endpoint we just implementing them, and we can split basically and do this with not only one or two developers, but with the whole team. On implementation stage, basically, you know that tests are important. I don't want to tell anything more about the test-driven development or something like that, because I believe you know everything. But I only would say that writing tests in the very beginning it works pretty good for us, because if you defined your endpoints for the service, you know what need to be implemented, and if you have additionally tests which are implemented based on these endpoints, you can easily split the development between development team and not have any disruptions or any blockings or any conflicts actually. So at the end, when implementation is finished, you need to connect your service to your service. And you need to do this as fast as possible. Because remember, we have a feature freeze or code freeze for some part of application. And your business expecting that you will deliver and remove this lock-in as fast as possible. And that's why after you implemented one particular service, use it. And basically, in our case, if you remember the layered architecture, we considering our monolith, current monolith, as presentation layer, yeah? And all the logic which was implemented in monolith and which was basically moved to the service, it needs to be replaced with communicating with the service. And in this case, monolith will do basically API requests or any other request to the service instead of implementation of code inside. And this makes the monolith smaller because basically the logic implemented in the monolith will decrease. And of course, API gateway would work also good because if you make many services, 20, 30 services, it's good to have one unified interface for communication of them generally. We are currently considering Kong as just a simple, very simple API gateway, which will basically allow to collect all the endpoints and manage them easily. So the release cycle for each service includes basically not many points, not many milestones. So first of all, as I told you, it's code freeze or feature freeze, let's say, on the application, so you don't want to make double work. Then it's development process, and then at the end you connect into your application, your service. And then you can just simply start with the next service and with completely the same pattern. And in such way, you will replace one by one all the logic from your application. And you will have at the end many services. You will have your service layer interface, and you will have your monolith, which basically, after some period of time, when you have already most of the service implemented, you can start splitting the monolith. You can start splitting it into smaller, lightware interfaces. Basically, it can be anything. It can be front-end application, which works directly with API. It can be back-end application. It depends on your basically sub-domains. Yeah? So you can split the monolith, and at the end, you will get rid of it. The only concern here is that if you have many services, they are not communicating only with monolith. They are communicating one with another. Because product basically needs to know about the price, or in this case, or availability is completely connected to checkout because checkout is asking availability and so on. And then we will have basically many connections between services, which basically will be like a monolith without monolith, because we still are having our components completely coupled. Basically, you will end up with another problem. And here it's a hard question what to do, because basically you splitted your monolith into services, but you're still communicating with them as with common components of monolith. And that's something we understood we need to find another solution. And actually we found it in event sourcing. Yeah? So basically every component, every service on some state change of its models can give this update to other services. Doesn't matter when the data will be requested by them. And basically sending this event to some unified, let's say, message bus, yeah, or event source system, will distribute it behind the logic without direct connection from service to service. And basically, we will have something like that. So we will have still our services. We will have API gateway to connect with the front-end layer, with the presentation layer. And each of the service will produce data to event stream, and depending on the need, each of other services will basically consume this data and replicate it in local storage if needed, or use it somehow depending on the service. And in this case, we don't have basically direct connections between services, which makes us happy. Basically, if we put it into our graphics, let's say about availability service as one of the services, and it's implemented like application, remember? And it has adapters. Yeah, so all the connections to all the different let's say edges, yeah, or different sources are done through the adapters, and basically the application itself doesn't know anything about the adapters. Yeah, so they are implemented separately, and they are basically their task is to connect to different sources. And one of the adapter in this case will be streaming platform, another adapter will be to API gateway, and another adapter will be, for example, for database. Yeah, so this is a very simple schema, but basically it gives us understanding that in this case we can basically use our application for different purposes. Yeah, so our service. This is about the hexagonal architecture. Yeah, so hexagonal architecture means that all the connections, all the inputs, outputs of the application should be implemented on the edges. Yeah, and basically the connectivity to other sources should not be really be inside the application. It should be isolated completely. So basically, currently we are on the very beginning of our journey, because we just, as I told you, started this process last year, and currently we started with thinking in frames of business, and this year we started already with implementation, so with our solution space. So I don't have any results like how it works at the moment for you, yeah. But I hope in some next PHP conferences I will report to you and tell the success story of complete migration of monolithic startup project into service-oriented architecture. So that's all from my side. Thank you for your time, and we have still some time for questions if you have.